Okay, hopefully you've already tried this problem on your own in your notes. So this is me walking you through the answer. If you got an answer of 6,250 grams of hydrofluoric acid, or 6.25 times 10 to the third, then you did this correctly, and you don't need to listen to this part, or you can fast forward. Otherwise, follow through with me and we'll set it up. The number I'm given in this problem is 9.40 times 10 to the 25th molecules of H2. So that's the number I'm going to start with. 9.40 times 10 to the 25th. In my first step, I'm going to do a conversion. And before I go any farther, let's take an inventory here and look at our mole map. They gave me molecules of H2, which would be like molecules of a substance A. And they asked me to find the mass of hydrofluoric acid, which is HF. So they're asking me to find a mass of a different chemical, which would be B. Take out your mole map and let's see what we have. They're giving me molecules of one substance. So they're starting me at molecules of A, and they're asking me to find a mass or grams of a different substance, mass of B. So what I'm trying to do is I'm trying to get from this box, molecules of A, all the way up to this box, mass of B. In order to do that, I have to do a couple steps. My first step is going to be changing my molecules into moles. In order to do that, I'll use Avogadro's number, which I know is equal to 1 mole of my substance A. So in this case, the molecules I started with has to go in the denominator. So I have molecules of H2 down here, and I have moles of H2 in the numerator. That's like my chemical A. The mole gets a 1 in front of it, and in the denominator I put Avogadro's number, 6.022 times 10 to the 23rd. This is always too long to fit on my paper. Then let's see where we're at. Our molecules of H2 would cross out. Right now I'm at moles of H2. So let's look on our mole map. From the moles of A, which is where I'm at here, I now am ready to do a mole ratio. A mole ratio uses the coefficients from a balanced chemical equation to convert that into moles of B. So my next step is a mole ratio where I use the coefficients. So in this step, I had moles of H2 on top, so now I'm going to put moles of H2 on the bottom. The chemical I'm trying to find goes in the numerator, which is the HF, hydrofluoric acid. Now, in order to fill this in, where do I look? That's right, I look at the coefficients. Right here, this HF has a coefficient of 2 in front of it, so I'm going to put a 2 in front of the HF. The hydrogen, which is the other chemical, has no number in front of it, which is the same as an understood 1. So those numbers I got from the coefficients in my balanced chemical equation. That's always where you get a mole ratio from. Notice my moles of hydrogen would cancel out, and right now I'm at moles of HF, hydrofluoric acid. Let's look back at our map. I'm at moles of hydrofluoric acid, so that's moles of B, and I'm trying to get to a mass, grams of B. So to do that, I have to go up this leg of my map. That leg says I can convert moles into grams by using the molar mass of my chemical B, which I get by adding up its mass from the periodic table. So right here, I'm going to squeeze one more times in a line on here. The moles of HF goes in the denominator because that was in the numerator here. So now I'm putting it in the denominator. In the numerator, I need grams of HF. And in order to fill in this factor, I know that I'm going to put a 1 in front of the mole because in a molar mass, we always use a 1. In order to fill in the grams of HF, I need to know the molar mass of my substance, which is hydrofluoric acid. So I need a molar mass of HF. That would be 1.008 plus 19.00. That gives me a total of 20.01 because I can only go to the hundredths place or 2 decimal places because my other mass only went to 2 decimal places. Now, my moles of HF would cancel out, and look at that, I'm ready to do a long math problem. If I do this whole calculation, what I would be typing in on my calculator is 9.40, and I would use the EE button 25. Remember that EE button takes the place of the times, the 10, and the caret. So you just push the EE button and you go straight to the 25. I would take that number, multiply it by 1, which doesn't change the value, and then divide it by 6.022 EE23. This is a place where your EE button becomes very important because if you don't use it here, if you're using times 10 to a caret, you would have to put parentheses around this whole number. But since I am using my EE button, I don't have to use the parentheses. Then I would multiply by 2, and then I would multiply by 20.01. Remember that the things where I multiplied or divided by 1, like right here, don't affect my answer, so I don't have to type those in my calculator. If it makes you feel better, you can. The answer I get for this is 6,246.89 ... To follow my rules with significant figures, I'm going to look at what I started with. 9.40 times 10 to the 25th had 3 significant figures. A 0 at the end after a decimal does count as significant. The power of 10 over here does not affect significant figures. So my answer should also have 3 significant figures. In order to write this correctly, I can write this as 6,250, because that 6 after the 4 means it has to get rounded up. Or I could put it in scientific notation, 6.25 times 10 to the third. Either way I write it, I need the correct label on there. The label in this case is grams of HF, grams of hydrofluoric acid. And if you got that on your own, congratulations. If not, I hope this helped. This next part of the problem, part B, is dealing with the same equation, but a different calculation. This time, the number they give you to start with is 20 grams of hydrofluoric acid. So in this case, the hydrofluoric acid is your chemical A. The chemical they're asking you to find something about is hydrogen. Specifically, they're asking you how many molecules of hydrogen you would get. So hydrogen here is your B. You might notice that this problem is kind of the opposite of what we did in the last problem. If you haven't tried this one yet, pause the video and try to figure this one out as the reverse of the last one. I'll walk through the answer with you here. To start the problem, I started out by writing down the number I was given. I was given 20 grams of HF, so I wrote down 20 grams of HF. Then, in my first conversion, I was changing grams of HF into moles of HF. So I had the grams in the denominator. Can you tell where I got that number from? That's right, that was the molar mass of hydrofluoric acid. In the numerator, I had a 1 in front of it because for a molar mass, there's always a 1 in front of the mole. For my next step, I was making a mole ratio because I had moles of one chemical and I wanted moles of the other chemical. For my mole ratio, because I had HF in the numerator to start with, HF had to go in the denominator of this step. In the numerator was the chemical I was trying to find, the H2. Now, to fill in my mole ratio, where did the 1 and the 2 come from here? That's right. They came from the coefficients in the balanced equation. So if you look back up at the equation, you see the H2 had a no number in front of it, which is a 1, and the HF had a 2. In the final step of my calculation, I was using Avogadro's number to change between moles of H2 and molecules of H2. So I had the mole in the denominator because that had been in the numerator of the previous step. And now in the numerator, I used Avogadro's number, 6.022 times 10 to the 23rd. When I did this calculation then, I typed all of this in my calculator, and I got an answer of 3.01 times 10 to the 23rd molecules of HF. If you want to know what that looked like on my calculator, it was 20.0 divided by 20.01 divided by 2 times 6.022 EE23. What I'm writing down here in green, you don't have to write that on your paper. I'm just trying to make it clear of how you would type that in your calculator. For your sig figs, because we all love sig figs, you started with 3, so your answer should have 3. That's why I wrote it as 3.01. And don't forget that power of 10 over there. That's the most common mistake, is people forget to write their power of 10. Make sure you get that number from the far right of your calculator.